The inverse for a matrix of order 3 or more can be solved using the gauss-Jordan elimination method or reduced row echelon form. The procedure involves interchanging of two rows or using elementary row operation. Given a matrix A, the steps to obtain the inverse of A using gauss-Jordan elimination are as follows. Step 1. Check whether the determinant of A equal to 0. If determinant is equal to 0, then the inverse of A does not exist. Step 2. Write the augmented matrix in the form of A, matrix A and I, where I is an identity matrix. Step 3. Reduce the augmented matrix to the reduced row echelon matrix form using ERO to produce a matrix of the form IB. I refer to identity matrix, B refer to the new matrix which is the inverse. So step 4, we can know that the B is actually equal to the inverse of A. Last step, check whether matrix A multiplied with its inverse A is equal to I. The order in which we perform the row operation is very important. The movement should be from left to right. Okay, so we must start to find here equal to, the entry here equal to 1, followed by 0, 0, go back to the diagonal, this one should be equal to 1, and then here should be equal to 0. Next, go back to the diagonal, here should be equal to 1, and then followed by 0 at this entry, 0 at this entry, and finally 0 at this entry. So the sequence to do the row operation is very important. So we must start here, 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 and then go back to the diagonal, 1, and then 0, go back to the diagonal, 1, then go up, 0, 0, 0. Example, let's find the inverse of matrix 3 by 3 here if it is invertible. Okay, if we can find the inverse. Okay, step 1, we can check determinant whether it's equal or not equal to 0. So if not equal to 0, then the inverse of A exists. Remember the formula of determinant for size 3. We can choose any leading that we want. Okay, provided we must remember the sign of the matrix. Here should be positive, negative, positive, negative, positive, negative, positive, negative, positive. So let's say we take ABC as the leading of the matrix. Here E, B, C, and then we just can use the sign here, positive, negative, positive. This is just the minor of leading A, minor of leading B, minor of leading C. To get this, A for leading A, the minor is this part. For leading B, the minor is D, F, G, I. And for leading C, just close this area and we get the leading, the minor of C for D, E, G, H. Where this is just the determinant for size 2. E times I minus F times H. So here we take the leading of 2, 3, and 4. So we get 2, and this is the minor, minus 3. This is the minor, plus 4, and this is the minor. So we calculate 1 times 2 minus 1 times 1, and then 2 times 2, 4, minus 1 times 1. We get plus 1. 2 times 1, 2, minus 1 times negative 1. So we get minus, we get plus 1, we calculate, we get negative 1, and the determinant is not equal to 0. Therefore, the inverse of A exists. So we can proceed to step 2. Step 2, write the augmented matrix in the form of matrix A and identity. So this is the matrix. So this is identity. So our main goal is to make sure this part become identity, and here we will get the inverse of A. Okay, step 3, we use the reduced row echelon matrix form or using ERO to produce the matrix of the form identity and new matrix B. Okay, let's look at this augmented matrix. So our aim here to make sure this one equal to 1. So we will do an operation at row 1. Okay, what will be the formula? We write back row 1. Okay, for this part it's easy because we want to change this entry become 1. So we know we want to make sure it's equal to 1 and our value is equal to 2. So to divide to make sure it's equal to 1, we just need to divide with 2. Therefore 2 over 2 equal to 1. So our new formula will be row 1 equal to row 1 divide with 2. Okay, next. We want to change here equal to 0. So we have row 2 and then we will have right back row 2. So which row we can help to make sure our row 2 becomes 0. Now our value of row 2 equal to 2. Let's say I choose row 3. So we have row 3 here. So the value of row 3 is equal to negative 1. So how we want to make sure our goal to make sure row 2 equal to 0. So you have to put 2 minus 2, right? So 2 minus 2 we get 0. So here we have already negative. So you just need to plus with 2. See, 2 plus negative 2 equal to 0. So your formula will be row 2 equal to row 2 plus 2 row 3. Okay, so we get this formula and we do the operation for row 1, the row 1. All row divide with 2. All row in row 1 divide with 2. And then row 2, we change all row 2, we change all row 2 with this formula. Okay, so we get this value. Okay, for example, I show one example. So 2 plus So 2 plus negative 2 equal to 0. 1 plus 2 times 1 equal to 3. 1 plus 2 times 2 equal to 5. 0 plus 2 times 0 equal to 0. 1 times 2 times 0 equal to 1. And then 0 plus 2 times row 3, row 3 equal to 2. And so on. Okay, so next we try to create the formula for our aim here. Now this one become 0. So write back, your formula is row, and the entry that you will do is row 3. Okay, so you write back row 3. So we can use row 1 to achieve this equal to 0, where our row 3 equal to negative 1. So to get 0, we just need to plus with 1. So 1 plus negative 1 equal to 0. So our formula become row 3 plus row 1. Okay, and then we also can, next we want to change this become 1. So we will have row 3 back. Sorry. Okay, boleh dah. Okay, as we see the value here, row 3, we want to achieve 1, but the value here is equal to 3. So to make sure it's equal to 1, we just need to divide with 3. Okay, therefore our formula will be equal to row 3 equal to row 3 divide with 3. Okay, so we get this formula and change all the row of row 3 and row 2. Row 3 using the formula here. Okay, you can see row 3 plus row 1. 1 plus negative 1 equal to, sorry, this one should be here. This one should be here. So meaning that we change all this. Okay. Next, we can change the row 3 here equal to 0. So we have this formula and change the row 3 value. Okay. The fundamental is the same. Now we want to make sure this equal to 1. So we just multiply with negative 6. So we can find all the value here, exchange. Next, we want to make sure this equal to 0. Okay, so by using the same method, we can find and exchange all the entry for row 2. Okay, next we'll find this equal to 0. So we want to make sure this one equal to 0. Okay, using the same method. Okay, you write row 1 equal to row 1 Then what can make it equal to 0? You just minus 2 row 3. And change all row 1 using the formula. Okay, and lastly, we want to make sure this equal to 0, last step. And we will use the formula and get all identity at this side and a new matrix B here. Okay, so we finish and get our goal, where here will be our identity and here will be our new matrix. Okay, step 4, the B is actually the inverse, and we can check finally if we have matrix A times matrix inverse A equal to identity. So we know that this is our inverse. Okay.